Melissa here, and today we're going to be learning and exploring freezing point depression. And at the end of today's lesson, we'll get to see freezing point depression firsthand when we make our very own ice cream. Are you ready? Okay, let's get started. Before we talk about freezing point depression, let's start with the basics. Matter. As we all know, matter is anything that has a mass and takes up space. There are 5 states of matter, but for today's lesson, we're going to focus on 3. Solids, liquids, and gases. Matter that's in the solid state has a definitive volume and shape. The molecules in a solid are closely packed together. Examples of solids are the chair you're probably sitting on, the screen you're watching this on, and this banana. Liquids do not have a fixed shape, but they do have a fixed volume. Particles of a liquid are closely packed together, but they're not as closely packed together as molecules of a solid. This allows for liquid particles to move around each other. Examples of liquids include milk, coffee, juice, tea. Now we're on to gases. Gases do not have a fixed shape and they do not have a fixed volume. They fill the entire space they're in. Gas particles are very far apart. They're not closely packed together like liquid molecules or solid molecules. Examples of gases include the air in balloons or the steam you see when you're boiling water. In each of the states of matter we just talked about, the molecules of those states are always in motion. They have kinetic energy, which is the energy of movement. Based on what I said about the molecules of solids, liquids, and gases, list these states of matter from least amount of kinetic energy to most amount of kinetic energy. Pause here and go ahead and think about it. I'll wait. Oh, you're back. Okay, so did you figure it out? If you listed solids, liquids, and gas in that exact order, then you're correct. Solids have the least amount of kinetic energy because their molecules are so tightly packed together. Gases have the most amount of kinetic energy because they're far apart and they have the ability to move. Liquids are in between. Now let's talk about phase transitions. Phase transition is the transition from one state of matter to another state of matter. This is done by increasing or decreasing the amount of pressure or the temperature. If you take a solid and increase its amount of kinetic energy, it causes it to melt, which turns into a liquid. But if you take a liquid and remove some kinetic energy, you allow the liquid to freeze, which returns it back to a solid. However, if you take a liquid and you add more kinetic energy to it, it can vaporize and become a gas. Now, if you take that gas and remove some of that kinetic energy, you allow for condensation to happen, and now you have a liquid again. Water is made out of hydrogen atoms and oxygen atoms. In one water molecule, you have 1 oxygen atom and 2 hydrogen atoms. That's why water is also known as H2O. Now, if we look at salt, salt is made out of 2 atoms, 1 sodium and 1 chlorine atom. When you take pure water and remove its kinetic energy by decreasing the temperature, you end up with a solid. The water molecules in this case are closely packed together. However, when you combine salt, water, and you try to freeze it, the salt gets in the way of the water molecules, which prevents the water molecules from being tightly packed together. So in order to freeze salt water, it must be done at a much lower and colder temperature. As we know, pure water freezes at 0 degrees Celsius. But if we want to freeze salt water, the temperature must be much lower than 0 degrees Celsius. This phenomenon is known as freezing point depression. Have you ever gone outside on a cold winter morning and you saw your parents or your neighbors sprinkle salt all over their driveway? Or have you ever walked to school and you noticed that there are a lot of small white rocks on the sidewalks and the road? Have you ever wondered why? Well, those white rocks you see are actually salt. By adding salt to icy driveways, sidewalks, and roads, it dissolves within this film of liquid water on the surface of the ice, which lowers its freezing point. By lowering its freezing point, it prevents the ice from refreezing again, so the roads, sidewalks, and driveways aren't slippery anymore. Because salty ice is so much colder, we can use it to freeze other liquids, which is what we're gonna do right now. Let's get ready to make our own vanilla ice cream. You'll need 1 cup of milk, 2 tablespoons of sugar, 1.5 teaspoons of vanilla extract, 1/4 cup of salt, 3 to 4 cups of ice, a small Ziploc bag, and a large Ziploc bag. Okay, let's begin. But before we get started, here's a tip. Put your small Ziploc bag into a glass or a cup like this. By doing this, it makes it easier for you to add in your ingredients. First, we're going to take our milk, sugar, and vanilla extract and pour them all into a small Ziploc bag. Make sure it's sealed tightly. For extra precautions, you can double up on the smaller Ziploc bag. Get our large Ziploc bag, our ice, and our salt. As you can see, I put the ice in the large Ziploc bag. And now we're going to take our salt and add it in. Now we're going to take our smaller Ziploc bag, double checking to make sure that it's sealed tightly, and we're going to place it into our larger Ziploc bag. Okay, now it's time for an arm workout. We're going to shake this bag for about 15 minutes, and by the time we're done, we should have ice cream. Okay, I'm going to go shake this now, and I'll report back to you later. And we're back. Now we have ice cream. See? Now before we dig in, let's recap what happened. The salt we added to the ice allowed for freezing point depression to happen. Our milk, sugar, and vanilla extract mixture started off as a liquid and lost some of its kinetic energy because of the temperature drop, which allowed for it to freeze. And now we have ice cream. Okay, it's the moment we've been waiting for. Let's try it. That's some good ice cream. Thanks for making ice cream with me today and learning about freezing point depression. As always, be happy, stay curious, and I'll see you soon.